Hey guys, welcome back to my channel. Today I'm going to cover an AWS architecture backend diagram for a SaaS application that I built called Resolve ReInvent. I'm going to share my screen. We'll get right into it. Quickly just show you the overview of the app. It's a getresolveai.app, and I have a simulator running here on the side for the iPhone 17 Pro. I did a previous video called Resolve ReInvent, Your AI Wellness Superpower, and that's on my channel. This video is going to be more on how I went and built the AWS backend. And there's going to be a future video on the front end, most likely. So the front end is a cross-platform Flutter application used AI assisted with VS Code and Claude Opus 4.8 for the most part, and previous models. It took me about 6 months to build this application, probably about 3 months total on the front end, 3 months on the back end. It's a full end-to-end consumer SaaS application. You can find more about me on my channel and my website called resolvesolutions.ai. Okay, let's jump into the AWS backend architecture. Before I do that, I just want to show you, I have a website, resolvesolutions.ai. I have a blog article on how I built the backend architecture of Resolve ReInvent using FastAPI, Lambdas, DynamoDB, and event-driven AI workloads. One of the goals that I wanted to do was I had to support multiple subdomains in a single Lambda for costs. I wanted serverless. So I wanted to be able to do journaling, moods, AI chats, insights, caregiver features, health metrics. And I want to do that all in a single Lambda as much as possible. But you'll find as we go over the architecture, I did break out a lot of async features using SQS queues and other Lambdas to handle those asynchronous and also AI calls out to OpenAI and other third parties like Google and Firebase and RevenueCat. For my RevenueCat is the paywall and provider. So when we get into the AWS overview, let's just start with, like we do with any architecture diagram, we have a bunch of clients, right? And the clients are going to have mobile application. This would be native iOS and Android. So we have mobile iOS and Android list. We also needed to have the web browser client for those consumers, right? So both mobile and web browser enabled. And then we'll quickly just add a container or layer here or tier for AWS. We'll just call it AWS Compute. And this is all serverless. In the future, I'll go over a video on how you might turn this into an enterprise application with VPCs and real subnets and availability zones and things like that. So stay tuned. At the end of the video, we'll talk more about how you would turn this into a full-fledged enterprise application. But for my needs, I wanted to really focus on serverless as much as possible, low cost. I'm the only author and I don't have a team of developers, so I wanted to manage everything I could as much as possible in a single fashion that I was comfortable with and low cost for getting a application off the ground. So we have an API gateway. Then we're going to need a custom authorizer. And then we have the actual Lambdas or API itself. So we'll just call this, the main API Lambda. And we'll go into more of that later. But then in between this, you're going to have some things for web, right, that we need to put in place here. So we're going to need a edge web delivery, if you want to call it that. You're going to have your Route 53 in this case for AWS. We're going to have our CloudFront. We're going to host a CloudFront distribution, content distribution network, right? And then we're going to have our actual S3, like static S3 web bucket, I guess you could call it, for your front end, right? Static assets, right? We can just style these out a little bit. So those are your mobile Android. Then you've got your edge, stuff at your edge, and then you're going to have your compute layer. So this alone will give you, here's the Resolve application where you log in. And in this case, it's Aaron, a test user, and Aaron has a number of journals out there. And the Lambda right now is actually firing up, and here's all the journal entries that Aaron has, right? And then there's different tabs, insights, chats, and things like that. So this is all pretty much the client mobile application hitting the API gateway, hitting the main API Lambda to do the work, right? And then we probably need to talk about the data layer out here. So in order to host all that stuff that Aaron needs and consumers need, we're going to have we'll call it the data stores. And the data store layer is going to have in it, our tier is going to have in it DynamoDB. And we're going to have different types of tables. So in Resolve, we have just the main table called Resolve. We'll call it Resolve DDB for now. And then we're going to duplicate this because we're going to have a couple other DynamoDBs in here. So we have Resolve, we have one for spaces, and we'll go into later. We'll get into a little bit later why we did that. Spaces. This is like all your communication and messages between for communities and also private spaces. Think of it like WebEx spaces, if you will. And then we have another database that we added for addiction handling and substance abuse. So we'll just call it addiction DDB. And this is spaces DDB. We're also going to we have S3 out here. We have soundscapes for sleep sounds. So when we come in here and if Aaron wants to see some of the soundscapes out here, Aaron comes in and clicks, busy restaurant and can hit play. It'll download that S3 music to your phone or device or your web client, and then it'll play it. There's also a screensaver, so you can put your phone down and save your screen at night. And then the little Lotus icon right here just floats around the screen. So your screensaver's on. So those sounds get cached to the device. So that's the S3 for soundscape. And then we have S3 for auditing down here. So I chose to audit information because it's a health and wellness and fitness. We definitely need to audit information, right? In case people need to go back and see not just CloudWatch, but we'll get to CloudWatch later, but they need to go back and see what they did in the app, right? Let's talk about third-party external services. So these are your data stores. We'll put these in blue. Let's put those in blue. Is there a darker blue? Yeah, we'll do that. And then S3, let's code those in green so they look like S3 buckets. And then we have another silo for external services. Okay, for external services, we already talked about earlier, we use RevenueCat for the paywall provider for iOS and Android. We won't really get into that today too much. I use Google Places API for your location-based services. So for instance, when Aaron wants to go over to Insights and wants to search for things near me, anything that has location, right? Stuff like that, find coffee shops. So when Aaron clicks on find coffee shops near me, it'll ask you what type of coffee workspaces are you looking for and stuff like that. So we could put like high-end coffee place. And this would use your location and then come back and tell you what are the top 10 places near you. I don't know what it's going to do with the simulator. I don't know what my location is here, but we can try it. While that's running, we'll just enter the other things that we need here. We're using OpenAI provider platform for all our ChatGPT, which you just saw there. And then there's another one for Firebase. So we use Firebase to handle all the authentication to Google and Apple. So I should probably put this up top, I guess. So Firebase is primarily used again as the main authentication provider. And you can see here that it came back with different locations for coffee. And again, I'm not sure exactly where this is. Oh, this is in California. but that's because it's a simulator. But that's pretty cool, right? So I'll move this over here. So these are the external services. And we could put those maybe in purple. So here's basically the logical tiers that we have. So we need one more box here. We'll call it ops, security, and backup. I want to make sure you guys know that we didn't forget these because it's kind of important. So in this case, we're going to need various keys in here. So Resolve API keys are here. We have the Resolve Firebase keys, credentials, what creds. And then we have Revenue Cat, Resolve Revenue Cat. Right. Those are the credentials that we have out there that we need to store somewhere in Secrets Manager. And then CloudWatch, we're going to need CloudWatch for logs, metrics, alarms. And we're going to need, actually what comes with a lot of this stuff is just your SNS topic for the alarms that we're sensitive to. And we also have our AWS backup. And so that would be the vault. That's about it for the backup stuff. So that concludes kind of your different tiers that we have in the application. Now we can get into part 2 of this, which would be the AWS backend architecture itself, system architecture. So I'm just going to add a new page, and then we'll start working on our backend architecture. So with the client, we're just going to grab a user. So we're going to need an authenticated user in this case, which, they might have a mobile phone. So we have like a little phone, I guess, right here. They're on their phone. And let's just add a gateway. So we know we're talking to from our previous diagram, right? This is our diagram. So the user is going to talk to the gateway. So this is what we would normally do, is just jump right into kind of the components we need. So I'm using the AWS 2026 shapes in Dry.io. So we're going to grab a gateway in here. And then in simplest forms, we're basically just going to have that gateway route to our custom Lambda. Let's label some of this stuff. This is going to be our Resolve ReInvent Lambda. And we'll say, we're also going to need a custom authorizer. So the gateway will talk to a custom authorizer. We're also going to label this the user, and then we're going to need our storage. So we're going to need to add DynamoDB for our database. Resolve. This is our main Resolve. Let's just put it lowercase. Resolve DDB. We know it's our DynamoDB, and I don't love the color, so I'm just gonna make it blue and make it white color. And then the Lambdas call DynamoDB directly. And this is the main Resolve DynamoDB. Now we have 3 databases. So we're just going to duplicate this down and call this one spaces DDB. And then duplicate this one down. Sometimes it's hard to type and present at the same time. Addiction DDB for addictions. Our addictions database. I can't remember if I made it plural or not. But for now, actually, let's just remove this. We don't need too many. You guys get the idea that we have multiple databases here. Single Lambda, multiple databases. So that's your serverless architecture in a nutshell. So everything that Aaron is doing here as a user, he's getting journals. If he's getting his journals, he's getting all the metadata. It's all coming from Resolve DDB. And then the actual chats or spaces, if you go into spaces and you look at like community chats, all these chats, because I support infinite scrolling. If you're familiar with WebEx or Teams, it's the same thing. I just basically implemented infinite scrolling, paging, and everything from that single Lambda to the Spaces DDB. The reason why I broke out the Spaces DDB as a separate database was pretty much just from a standpoint of ease of schemas, because it's schemaless, right? So the Resolve DDB is primarily concerned with user data, metadata. user profiles, pretty much user-centric. And then the Spaces database is also concerned with users, but there's also other users and community users at play. So as you guys know, you're able to have like something like 20 GSIs in your each database. So I have a single table design as part of each of these, but I broke them out because I figured they would grow differently in size and have different performance metrics over the long term. And as I added more and more features, I wanted to just have keep things separate and not tamper with things that were working, because Spaces came way later than, the rest of the app. So it was really easy to build a new table just to house all the spaces, community spaces, and partition keys, sort keys, GSIs, things like that. And I added yet another table just for the addictions, just to keep it easy and different, I guess you would call search paths, right, through your database to handle different various things that you needed along the way. So that's all synchronous. So from a standpoint of a user hitting the database, right, getting information, adding a journal item, I am documenting the backend, the AWS backend architecture. So when you do that, when you hit save, right, now this part is that most of the app in terms of reading is synchronous and uses the API gateway. And I can now tailor that to, it used to be 29 seconds for REST API, but now AWS, since I think 2024, AWS allows you to go beyond 29 seconds for your API gateway, mostly probably due to OpenAI because AI operations take longer. So, but then when I add a new journal item and I do spell checking, I wanted that to be an asynchronous operation. So you can see here as we add an item here, like this is an asynchronous operation. So when I save this, I immediately get a 200. And then this front end is just polling for that ID that I created. And it's just going to return when the journal's created. So in this case, it creates a DynamoDB entry. It writes processing in the title and certain eye catchers, right? And then the app knows to poll for that ID. And then when it's done processing, it basically just says, put it on the screen and stop polling. That's just a simple way to do asynchronous. And we'll show you how I do this now with SQS and Lambda. But this is a cool feature because the voice journaling and the text journaling, I don't have voice right here for a simulator, but for the text journaling, and if I turn on AI autocorrect, I'm not only saving it to the database, I'm also calling OpenAI to do a spell check and actually infer the title. So basically the prompt is basically, as a system, well, the general prompts for all of Resolve is like, you're a therapist, but in this case, you're not a therapist. You're basically just a spell checker, expert spell checker, grammar. And your job is to make sure that this sentence is spell checked and grammar checked, and then also infer a title for the user and give it such a name and such a length in terms of constraints. Okay, so let's get into some of the asynchronous processing now. I'll bring over my handy dandy user Aaron here, who has journal items out there, insights that he wants to run, and then his chats, sessions, and spaces. Various things in the app are going to be asynchronous now, and we're going to need queues and separate lambdas to handle kind of an asynchronous nature of the app. So I've created a couple of examples. So we're just going to go in and leave ourselves a note. This is an example of an async journal item operation, right? And I save that, and the application now is just polling for the backend. A DynamoDB entry was saved, and it's saved as processing. And then we call OpenAI in the background to do spell check, grammar check, and then creating a title automatically. So those are the two operations we would use. First, write it to DynamoDB, get the ID of the item, and then the application then will kick off an SQS Lambda that does the spell check, generate title, check for grammar, and then update the database with the results. And then the front end application in the polling, it would basically poll. It's not necessarily event driven back to the client, but the front end would poll because it's a simple client and would eventually time out, but it would poll for a period of time and then update the user in terms of the title and the operation and then stop polling. So this is an example of the back end is async and the front end is a simple synchronous operation where we just check for polling. So let's build the queues out for that. So we have 3 types of queues in the system. We have a task queue and we're going to need a Lambda that goes with that. So we're going to need a queue and a Lambda function. So this would be our task function. And this would be things like voice journaling, and that gets called from the actual Lambda to put that on the queue. And then we have, let's just line these up. Then we have a couple more queues that we need to add. Let's duplicate those. And we're going to need a queue for community moderator. And that queue calls them. We have DL queues for each of these queues, but I'm not going to draw them because they take up too much space. So we have DL queues in our system that I'm not going to draw because they take up too much space. So we do have dead letter queues, which are queues for each one of these that handled failed deliveries, retries, things like that. So those are all part of the system that not going to get into. Like I said, it's a little bit outside the scope, I guess, for now. So there's our SQS queues with our functions that we have. So the 3 different asynchronous natures of the app that we have in here. We showed you one, which is a task queue that just does the spell check. Then we have a moderator queue. So if I go into Spaces, this DynamoDB table with its GSIs are highly optimized for creating messages for the community, searching for messages, doing replies, reply to, right, parent-child type of things, infinite scrolling, things like that, and getting data from the most recent first, things like that. So if we go into the vent space, actually, you can vent and leave a note for the community. I'm really excited about the weekend. I hope it doesn't rain. So if you post this note to the community, you can see it's in review. And what's happening at this point is the Lambda saved it to the database, marked it as review. Only I can see this note because I left it for me. And then the community moderator, SQSQ, picked it up, called the Lambda. Then the Lambda basically wrote back to the Spaces database. So that's one operation there. And then the application, just like before, continues to poll this message, and it would actually, the review indicator when it's done would be cleared on the app side. So one of the things we can do is actually demonstrate the dimensions processor, which is the last queue we have here. And so we'll call this dimensions processor functions. So you can ask Lotus, the chatbot, what do you think a good hike would be in New Hampshire if I wanted to go on a hike, right? And so that will, again, it'll actually fire off the community moderator for what I just typed, but at the same time, the mention processor gets handled. And if there's a mentions in the note, a mentions processor will get handled, and then it'll also call back and it'll respond back also to the Spaces. So I'd actually be saving to the Spaces database, but they also have to talk to, those same functions have to talk to the other database as well. There is the main database. So we'll just draw both of those lines really quick while that's processing. So in this case, it says Lotus posted in Vent. So that would be an FCM notification. So it said, sure, great hikes would be Mount Willard, Franconia Ridge, check weather. So these are all different hikes you can do in New Hampshire, right? I'm familiar with the Franconia Ridge. I know where that is. So that's kind of cool. So that would be this was a combination of the community processor, which I don't know if we mentioned, but in a previous video, I talked about how it works, but there's a prompt that checks an OpenAI call, right? There's a prompt that checks for hate speech and things like that. and it only allows people to talk about things that are relevant to their mental health. And there's a lot of things in terms of guardrails that are put in place. So certain things are allowed, certain things are not allowed. We won't go into the details on that right now. But that's how the moderation and the mention processors work hand in hand together, both pretty much basic RAG, right? And AI in this case, nothing fancy, there's not a lot of agentic going on here. That's another problem for another day that we'll talk about. But then while we're at it, we're going to need to build out the other things that happen. Let's just build a box here let's add a box for the OpenAI API. Our single Lambda calls OpenAI, but also our mentions processor calls OpenAI, as well as our community moderator. We talked a little bit earlier about the soundscapes. Those are all stored in S3. So when you listen to soundscapes, all those sounds are stored in S3. So we're going to need an S3 bucket. And I'm just going to put these down here. These are just global services, right? So I'm going to put sleep sounds, and we have audit. Our audit trail is also done. So audits. And then other things that we need that are typical of an AWS environment that we'll just put out here. We're going to need Route 53, we talked about for DNS. So we do have DNS in our system, get Resolve AI.app. So we have certificate manager that handles our certificates for ACM. So we'll just put Route 53, put DNS in here, put certs or ACM. And then we use IAM, Identity and Access Management for our roles. So we do have role-based solution in here. We are using CloudWatch as well, and just move these down a little bit. And then we use Secrets Manager. So these are all the different services that we're using that are global services, if you will. And then we talked a little bit about RevenueCat is the provider of choice for the paywall for iOS and Android. So with RevenueCat, I'm just going to put it over here for now. And the Lambda does make calls to it. And there's also a webhook that RevenueCat calls back our webhook into our gateway. And we'll just call it webhook. So that's how that works. And then we have Firebase. We talked about our authentication is handled by Firebase. And we have Firebase does our OAuth 2 JWT access token. We can go into another video on how that works. But basically the user is sent to Firebase. Firebase calls Google or Apple identity provider. I'll just show you really quick. I built a diagram already for what the authentication looks like. The user signs in with the mobile app. Step 1. Step 2, we have the auth process where Firebase is used as the authentication provider. Step 3, we use OAuth 2 to Google identity provider or Apple. We then return back the JWT access token to the user, to the client. Then step 5, we call our API gateway with the bearer token. And then we get the response. Then we call our custom authorizer. And we get we also have our public signing and keys validation. We get the auth response that you've signed in. And then at that point, you have your JWT access token that's used for each call. So that's how the authentication and authorization works. I just wanted to give you guys a quick summary of that. So we have Firebase, like I said, up here. We're going to need one more service that we forgot to add. So for different scheduling and events and things like that, we use EventBridge. So I need an EventBridge service that handles all our Firebase notifications. So we schedule jobs, and those jobs will reach in and grab information from Resolve DDB and then call Firebase to do FCM notifications. And so we're using the Firebase Cloud Messaging notifications through the EventBridge that essentially sends that back to our application. So a couple things going on here in our community processor, in our mentions processor, I should say. When you mention somebody's name, we also fire off a FCM notification to Firebase, which then comes back to the application, to the user's client, right, to the mobile app. So we can kind of demo that for you really quick. So can you let me know what a good first hike for a newbie would be in New Hampshire, White Mountains? So this is asking Lotus for an advice on what a good hike would be. And once Lotus responds, so the community moderator fires off, then the mentions processor fires off. And if it sees that I was mentioned in the tweet or if I was mentioned in the post, then it'll send an FCM notification back to my client. The way I architected it is whoever logs in last is receiving notifications. So if you're on the web, if you're on your mobile application, or if I'm on my simulator, I'm not going to get 3 notifications to 3 different devices. I'm going to get a notification to the last logged in device. So you can see up here, it says Lotus posted in event. And then I can refresh the page for me. And then it says for a first hike, you would want to try this one, blah, blah, blah. So that's kind of cool. That's how the notifications. So this concludes the AWS backend architecture. Again, very simple serverless model, client, mobile, web, API gateway. And actually, we didn't really show the web browser interaction. We talked before about the Edge, Route 53, CloudFront, and S3. We could easily add S3, the content distribution network over here. But I think I'll leave this off for now. This is your basic serverless model with an API gateway, REST APIs, regional REST API calling, a single Lambda to DynamoDB with SQS queues, moderator queues, task queues, mentions processing, all based on Lambdas that do work asynchronously. And then we have OpenAI is for our AI processing. We use RevenueCat for the paywall, and we're using Firebase for the authentication layer. So the next section, we're going to go into how you might design this for AWS Enterprise and what we might do differently in the back end and how we would design it more for a larger team that's focusing on scaling this out. So we would talk about reliability, scalability, more observability and metrics and reporting, things like that, all the things that come with enterprise. But for now, this is your basic AWS consumer SaaS backend in a box with a cross-platform Flutter app for iOS and Android native and web. Single code base, single repo, right? So single repos with GitHub actions for each of these. There's a single repo for the backend API. This is all with assisted AI engineering starting with Sonnet and then Claude Opus 4.5, 4.6, 4.7, and then lastly 4.8. And then unit tested. The beauty about AI was I was able to generate hundreds and thousands of test cases that would normally not be able to do. This took I would say about a week or two to just get the basic aspects of the application working with Dynamo, but then it took about 3 months to get a really full-fledged, bulletproof user experience for journalings, moods, all the features that we have, spaces. So all the things that you saw here with the metrics for your moods, your journaling metrics, your journal items themselves, the insights, which is a ton of metadata that goes into DynamoDB, the chat, all the chats that we track and organize and save in the DynamoDB, the community spaces that you can access. And then there's also private spaces that are there. And this is generated by, this is fake data, but it's generated for me. And then you can search for location-based spaces where you can join and talk to people that are only in your nearby community. Then there's a whole bunch of other stuff that we didn't show you, right? There's the healthcare part of it. Health and fitness connects to your Apple Watch Health Kit. Wellness and recovery. So this is an example of just how you would handle like alcohol, days sober, things like that, eating, emotional eating, shopping. You can add all the different metadata that you can see here was added easily and stored in the backend. So drug, alcohol, gambling, food, stuff like that. The user adds that automatically to what they're tracking. Finding doctors, breathing exercises. So you can do breathing. Then there's soundscapes that we showed you already, where you can listen to sounds, sleep sounds. Then there's Care Circle for adding loved ones and managing how your loved ones are doing over time, and a lot more, right? And then different themes. The themes are all generated as well for different palettes. And I just chose the ones that I liked. And there's also light mode, dark mode. And then we talked a little bit about the guided tour. There's a guided tour, and then there's the actual guided path, which is the onboarding that users experience, and then they hit a paywall. But that's it. Hope you liked the video on the backend architecture. I'll put the AWS Enterprise components as a separate video. So leave me a comment. Let me know how you like this. And I'm going to do some more of these videos. The next video is going to be an agentic video that will show how I built another application that does document management using RAG, and then OpenSearch vector database, and then Agent Core with a Strands SDK, and Agent Core in the backend, and Bedrock, and how I managed all that. So that's going to be more on the agentic side. Leave me a comment. Let me know what you guys think, and I'll see you guys on the next video. Thanks for watching.